All right, so if I want to do 6.2 number 5, which says f of x is e to the x,
Cool.
and I would like to draw on the same graph f of x, 4f, minus a half f, and minus 5f.
Okay.
So first things first, I'm going to need one big equal sign, plus sign, whatever this thing is, with maybe labels.
The fly on the wall, right?
X's and Y's at least. Okay? Now, I would like to draw first e to the x.
Cool.
What does e to the x look like?
Like comes down on the right. First quadrant goes up, and then kind of just, I don't know, something like
Are you
that.
drawing something that doesn't pass the vertical line test, Levi?
I don't know. Goes in a circle.
It's like a roller coaster thing.
No, it just goes down. It just goes
It
down.
just goes down.
And then like it goes.
And then there's the loopy?
No, it goes to start it goes to start bending and it kind of stops. I'm a graphic guy.
It's like
Half
the parabola. It's an exponential downgrade.
Yeah, this is like what would happen if you released like flying snakes in the Columbia Bowl.
Well, really, this is the function for that.
Yeah. This is what their population would look like. Right? There would be like one flying snake. Right?
Okay.
Like at time 0 there would be one flying snake, and then they would explosively grow, right? But the rate at which they would grow would be basically the number of snakes there
How
are.
are they growing if there's only one snake?
You know what, fine, let's count it in breeding pairs. They're horrible. Okay, so what that looks like is the rate of growth of the snakes picks up, right?
Okay. And
And
time?
if I think about back in time, this gets a little weird. So for back in time, it's easier if you think about there's a kilogram of bacteria.
Mm-hmm.
Well, a while ago, there was less than that, but they still grow in this same way, right? The rate of growth is proportional to the population.
Okay.
In this case, I'm assuming the rate of growth actually is the population. It's a little screwy, but bear with me. So I get something like this headed back in time. Those should meet.
That's pretty funny.
So this is exponential growth, right? And that happens, like this guy says, rate of growth is population.
Wait, e to the x always is rate of growth?
Yeah, anytime you see an e to the x, you can think the rate of growth is proportional to the population.
Wow.
That's why that number e is important.
What is
What is the number e?
Yeah.
Yeah, so this doesn't, no carrying capacity is
So
involved.
is e a constant?
Yeah, e is a constant, it's like 2.718.
And then x, wait, you said 2.7 million?
No, 2.718 and then some stuff.
Oh, okay.
Like it's a transcendental
And then-
number, so it's
Okay,
kind of
and
a
then x
pain.
stands for,
And then x stands for the input, right?
The time?
Yeah, the time. in this.
okay.
You guys cool with this? These are useful
How do you
because
divide-
they do exponential growth in populations. They do
How do you derive b?
calculus. So they do exponential growth in populations. They do continuously compounding interest. They do the rate at which your beer cools or warms up when you pull it out of the fridge. They do the
How do you do something? Do you get a number?
they do radioactive decay. Yeah, there's a bunch of stuff.
I just want to know how you get a number that works for so many different versions of growth. It's just such a good function, I guess. It's just
Yeah,
a
so
very
it's
simple function.
that e comes up anytime you can say the statement the rate of change is proportional to the amount.
Cool.
Right? So in the pulling a beer out of a fridge, that example is the rate of change of the temperature is proportional to the difference between the temperature of the object and the temperature of the room.
Okay. Okay. Makes sense.
Cool? So if you want to explore some more of this, take DEs.
Take DEs.
Differential equations class
Oh,
is all about solving e to the x's.
That's cool.
Like fundamentally, that's what we do. We play with e to the x every day and all the time. Okay, so I have my e to the x picture. That one's f. Now, I would like 4 times f.
Okay.
So what should that be fundamentally?
Be like 4 e to the x.
It'd be like 4e to the x, man.
So it's like after, so you're affecting your outputs, which means you're affecting y's, and you're
Okay.
multiplying. So you're gonna get, are you stretching really?
Yep. So this is a vertical stretch. So the vertical stretch, you need to stretch everything out by a factor of 4. So this is, instead of starting with one flying snake and assuming it undergoes exponential growth somehow, you start with 4 flying snakes and assume they undergo exponential growth.
Four flying snake breeding pairs.
Right? So instead of 1 here, we do 2, 3, 4, and then we need to stretch this whole thing out by a factor of 4. So every one of these distances is going to get multiplied by 4. So to get another point, I might go over here
Makes sense.
and go 1, 2, 3. Cool.
Yeah.
And then we kind of connect the dots here. Right? So, oh god, we actually connect the dots. So we get something like this. And I kind of bobbled that. Cool? All right, next thing's next. How about minus a half f of x? What do you got there? You got 2 things.
Well, yeah, you do have 2 things. We're gonna flip it eventually.
You gotta.
Okay, so there's a flip from the minus sign. Is that a vertical flip or a horizontal?
Horizontal, vertical.
It's
One of the
flip over
two.
the x-axis.
Pick one and
It's a flip
decide.
over the x-axis.
It's a flip over the x-axis because it's happening to the
Y's.
To the
y's. So that's a vertical flip
and a vertical compression.
and a vertical compression. How do I know it's a vertical compression?
Because you're multiplying by a number that's smaller than 1.
So it's a compression because I'm multiplying by a positive number smaller than 1.
Well, you're okay. Yeah, you are. It's a -1 multiplied by a
Yeah,
positive 1.
so it's a -1 times a 1/2, right?
Yeah.
So that's a vertical compression and also a vertical flip.
Fair.
I never told you what to do with negative numbers, right?
It's true. It's true. Because if you have -1/2 in parentheses,
Yeah.
that would
So
change
you
it.
think about the negative as a flip and the other thing as the compression or stretch that it is.
Yes.
So how do I know these are happening to the y's though?
Because it's outside of the little home that the x lives in.
Yeah. Because you're doing f to x first, and then you're multiplying by this stuff. So this is going to be the same function as the black one, except
On the other side.
half as high and flipped over. Is that half as high?
Yes. Yes.
Something like that.
Oh, my God.
So if I wanted to be precise about that, I'd get my ruler out and go like this. Okay, so this distance, half of that's about there. I underestimated a little. It was better the first time.
It's good.
Cool.
The model.
We believe in you.
Okay, so this is minus 1/2 e to the x. Oh, I forgot to label my orange one. Whatever.
It's okay.
And pick one.
Ooh, pick one.
I thought you said pick one.
Pink one. The pink one.
Right.
And not you guys this time. Somebody else.
You flip it over and stretch it back.
Flip it over. Is that a, which kind of flip is that?
Flip the x-axis.
Yeah, it's a vertical flip over the x-axis. Perfect. And multiply everything by 5, right? The y's are going to get multiplied by 5, which is going to be a vertical stretch. So stretch it out first. So it's going to look a lot like the orange one, right? Except a little higher.
Yep.
And then flip it over. So we're going to get something like this. Cool. Questions, things? What's a population interpretation of -5e to the x?
I guess I was trying to.
Everything's dying at 5 times the normal rate of growth.
Yeah. No, if you raise it up above the x-axis, it would be the population decline. This isn't. This is
Populations don't decline that way. Populations
Yeah,
decline as e to the minus x.
maybe a ramping up. This is a negative population.
So populations decline as horizontal flips, not as vertical flips. Because this thing's outputs are fundamentally negative, right? That's like a population of anti-sheep or something.
That's what I was thinking. I was like, this must be like
Or it
anti-thing.
could
This
be
is
like
like
Yeah.
negative
it could be an
space.
outbreak.
This is like,
Anti-things is probably a good way to think about
yeah,
this.
okay. There, I was about to be really confused.